All right, so yesterday we talked about arithmetic sequences. That was where you had a common difference between each term. So these are geometric sequences, which will not have that common difference, obviously, or they would be the same thing. So this is a sequence in which the ratio, not the difference, the ratio between any two consecutive terms is constant. So it's a sequence in which the ratio between any two consecutive terms is constant. Yesterday it said difference instead of ratio. Ratio mathematically should make you think of what? Fraction. Okay, so basically you're just setting up a fraction to see if you have a common ratio. So then the common ratio, which is what it's called here, is the numerical ratio between any two terms, and the variable here, instead of being D for difference, it is R for ratio. So when you're looking at these, I mean, you're going to have to eventually be able to determine between a geometric sequence and an arithmetic sequence. But if you know that they don't have a common difference, then you start looking for the common ratio. So to figure that out, you would take the second term and put it over the first one, like 24 divided by 8, right? And that's 3. And then 72 divided by 24 is also 3. Like, you can't just check the first one because it may also have a common difference. But if you can divide, if each one of them is basically, you're multiplying by 3 each time instead of adding, like I'm multiplying by 3, then your ratio, your common ratio, is 3. Does that make sense? So it asks us here, it says, determine the common ratio, then find the next 3 terms. So common ratio, and then I would take 216 and multiply it by 3. What do you get? 648. You did that faster than y'all could type it in the calculator. And then 648 times 3. 1944. Yeah, okay, so at least he admits it. He could have done it in his head, though, I know. And then 5832. Easy enough. And that's, and again, you should be capable of doing it without a calculator. Yes, it can make it faster sometimes, but not always. All right, so let's look at number 2. It's going to have a common ratio, and we still think about it being multiplied by something, not divided by something, right? So clearly it's going down, so you might be thinking about it being divided by something, but remember, you have to take the second one, this negative 128, and put that over 512. And then the calculator will reduce it for you, so you don't have to reduce it by hand. What do you get? 1 over 4. And then what about when you do 32 over 128? Is this the same thing? Yes. Okay, so, but it's not 1/4. What is it? It's negative. Good. You got to have that negative. So this is going to be a negative 1/4. So R is equal to negative 1/4. That's the first part of the question. And then the next 3 terms, well, what's 8 times a negative 1/4? Positive 2. And then 2 times a negative 1/4 is going to be negative 1/2. And then it's going to be a positive what? 1/8. Yeah. There you go. All right, easy enough? Now understand how to find the ratio? We don't need to do 3 and 4. So just like with the arithmetic, though, there's a way to come up with the equation because it's not, you can't just say always multiplying by 3, and we can do recursive and say a sub 1 is 8, and then you just multiply by 3 each time. But if I want the 58th term, I got to have terms 1 through 57 to get there, right? So we would rather not have to do that. So we have the nth term formula here. So the nth term of any geometric sequence can be found using this formula. A sub n equals A sub 1 times R to the n minus 1 power. and where a sub 1 is the first term again, and r is the common ratio. Everybody good with that? Okay, so let's start with number 6. Okay, so number 6, the first thing I got to find is, well, I know that this is a sub 1, right? And then I got to find the ratio. Okay, is it 1/2? Yes, and it's a positive 1/2 or negative? Positive. It'd be negative when they alternate, right? So it's just a positive 1/2. That means I get a sub n is equal to 1/2 times, no, 1/2. Dang it. Oh my goodness, I'm already messing up. Negative 2400, yeah. Negative 2400 times a positive 1/2 to the n minus 1 power. And when it's a fraction, you have to put it in parentheses. Otherwise, it looks like it's just the numerator that's going to that exponent, and that's not okay. Can I multiply these two numbers here? No, I cannot multiply 2400 and 1/2 right here, right? Order of operations, you have to do your exponents first. There's a reason that it's separate there, so don't do that. That's a very common mistake, okay? And then that's it, you're done. Because all we are doing is writing it, yeah. Oh, no, we're not done. No, sorry, we're not done. Well, we're done writing the formula, though. We don't have to, like, clean it up or anything. But I do need to find a sub 8. So a sub 8 is equal to negative 2400 times 1/2 to the 8 minus 1 power. And you can do that in your calculator. Make sure you're careful about how you're typing things in so you're not making sign errors or exponent errors. Either one. Negative 75 over 4. Do y'all agree with that? You're not that far. Okay, I'll wait. I want you to get that far, though. Don't just stop and write this down. I want you to type it in. I'm not trying to rush you because I want to make sure that you're getting the same thing. Okay, we agree? Okay, so if we agree, then I want you to do number 7. Number 7, yes. It's a big number, yeah. Good. So for r, we should have gotten negative 6, right? And then a sub 8 is going to be equal to 7 over 36 times negative 6 to the 8 minus 1 power, or the 7th power. So a sub 8 is negative 54,432. Any questions at all? All right, good deal. Flip it over. And we are going to jump to number 11. All right, so over here off to the side, I'm going to rewrite that little equation. We have a sub n is equal to a sub 1 times r to the n minus 1 power. So this says use the information given to find the indicated value. So they gave me a1, they gave me r, and I'm looking for a6. So a sub 6 is equal to a sub 1, which is 240, times r, which is negative 2, to the n minus 1 power. So that is the 5th power, 6 minus 1, and that's 5. Are we good? Easy enough? All right, so now number 12 is a little bit different. Number 12 gives us a sub 2 and r, but we want a sub 10. So before we can get that, we need a sub 1, right? So we got to find that. We got to use what we have to find a1 so we can do the rest. So that means we use a2, which is negative 8. That's equal to a1, which we don't know, times r, which is 4, to the n minus 1 power. What is n in this case? 2. So 2 minus 1 is 1. So basically, I just divide by 4, and I get a1 equals negative 2. Okay. Yes? Once I've got that, now I can substitute that in, and I actually want a 10. So a sub 10 is equal to a1, which is negative 2, times r, which is 4, to the 10 minus 1 power, which is 9. Oh, wow, right? Because this is not a linear progression. Some of these are going to jump up really quickly or down either way. So negative 524,288. What questions do you have? You should. I mean, I wouldn't count it wrong necessarily, but it's easy to get lost in your own numbers too. All right. Did you figure out what went wrong? All right. Now, let's look at number 13. 13 is the same kind of way, so we'll do this one, then I'll have you do 14. So I have A5, right? And in R, I want A11, but I need A1. So I'm going to have to put in 1/4 is equal to A1, which I don't know, times R, which is 1/2, to the n minus 1 power. What's n right now? 5, so that would make this right here 4. So the first thing I want to do is take 1/2 to the 4th power. What's that going to be? 1/16. So I have 1/4 equals A1 times 1/16. Then what am I going to do? Multiply both sides by 16, so what's A1? 4. See, don't even need the calculator. Okay. So then I find A11, that's equal to A1, which is 4, times R, which is 1/2, to the n minus 1 power, which is 10. Now this one, I just put all that in my calculator if I were you. No skipping. One over 256, good. All right. So you got the hang of those, right? Let's do another one that's a little bit different. Let's look at 15. Okay, 14 is just like those last two. So on 15, it's still, we have A1 and A6, and I need A12. So what am I going to have to find before I can find A12? R, okay? I need R, right? Because I got A1, I need R. So I know that A sub n, which would be this A sub 6. So 486 is equal to A sub 1, which is 2, times R, which I don't know, to the n minus 1 power. So that's 6 minus 1, which is 5. Okay, everybody with me? So we divide both sides by 2, and we get 243 equals R to the 5th. What do I need to do to get R by itself? I have to find the 5th root, right? Okay, if it's a square, I do the square, yeah. 5th root, like, it's the 5th root. So on the calculators, find the button that is, you see it? It's right next to the green hex. You have like 2 little squares, so right under replay, and there's a green hex. So if you do shift and then that hex key there, you get the little boxes. You see what I'm saying? Good. It's 3. So you put the 5 in the first box, and then, good job. Equals 3. right there with the green. It's right here, that little orange thing. Do y'all see it? Did y'all find it? I can't. Yeah, there you go. So when you do that, you get two little boxes to fill in that look like this, right? So you're going to put a 5 here and a 243 here. All right, we good? That's R, but I got to keep going. So now that I have R, I want to find A12. So A12 equals A sub 1, which is 2, times 3 to the 11th power. That's a big number again. Not a million. 354,294. Questions? All right. Now, 16 is even a little bit more different than that. Lots of things. We'll get there. A sub 4 and A sub 7 is what they gave us. We want A2. So I don't even have A1 or R, right? But here's the deal. We don't necessarily have to find A1, right? We're going to take A7 that we have, this negative 75 over 128, and I don't have A1, but that's okay. I'm going to use A4 in that place, but that's going to change something else, okay? So this is 75 over 2 instead of A1 times R, which I don't know, right? The exponent has been n minus 1, this subscript minus this subscript, right? So this subscript is 7 minus 4 instead of 1. So these are, it is always, this exponent is always n minus 1 because that's the subscripts of these two a's, right? Look up here. Like this subscript minus this subscript. So as long as I do that, I'm good. It's 7 minus 4, and that's why it's 7 minus 4. We all okay with that one? All right. So then I can go ahead and divide both sides by 75 over 2. What's that going to give me? No, but be careful. If you're going to, I wrote down the wrong number. It's 75 over 128. Sorry about that. So if you just copied down my number, I wrote the wrong thing. It's negative 1 over 64. Yeah. Or multiply by the reciprocal, either way. So you get negative 1 over 64 is equal to R cubed. There is a cube root button, I think. If not, yeah, there is. And if there isn't, you could use the same one you did for the fifth root. You just have to type the 3 in. But when I take the cube root, what does R equal? Negative 1/4. That negative is important. So there's my R. So problem is, I still don't have A1. Now, I could go find it at this point, but I still don't even have to do that because I could employ the same idea here and do, all right, I want A2. That's equal to, I'm going to stick with this 75 over 2 thing here. Of 75 over 2 times R, which is negative 1/4, and then it's this subscript minus this one, so 2 minus what? 4. Okay, which is going to be a negative 2. And if you use that exponent, you'll get the same answer as if you go and find A1. Okay, ask me questions. Got questions? What questions do you have? It won't give you A1. That won't give you A1. That'll give me A2 is what I want. I could go find A1 by doing some more steps and doing the same thing we did on the other ones, but I don't have to because I can use the pieces that I have. Because it's asking me for A2. Positive. All right, how we doing? We good? That one's a little funky, but okay. All right. Now we have recursive and explicit for these. So the first thing we want to do is you figure out what's going on in the pattern, right? What is R here? Yeah, R is equal to negative 5. You agree with that? That means we're multiplying by negative 5 every single time. So for the recursive, This is the one where we identify the first one. A1 is equal to 2, which means that A sub n is equal to negative 5 times the one before it, which would be A sub n minus 1. And that's when n is greater than or equal to 2. Remember, we defined A sub 1, so we got to start with 2. There's your recursive. Okay. I will give partial credit. All right. Explicit is where we do the other one, right? So we're going to do, it's the A sub n equals A sub 1 times r to the n minus 1. So our explicit formula would be A sub n equals 2 times negative 5 to the n minus 1 power. All right? Huh?
On the test, I did that, but I forgot to put the line under the n is greater than 2. I forgot to put the line.
Okay, which makes it wrong. Okay. All right. All right, so go ahead and y'all work on, y'all do 18. There's not going to be any corrections on this quiz. You got to correct other ones. Sorry, Charlie's. No, because we only have a couple minutes left. You're going to have to wait. Yeah. Only about 5 minutes left. Okay. Number 18. Did you finish 18? Yes, I said do 18. No. Eddie, what are you doing? Dude, I think you have lost your mind. Come sit your butt down and do number 18. Whichever one you, since we defined the first term, I can't, if I substitute in 1 doesn't make any sense because 1 minus 1 is 0. So if I define the first term, I have to start with the second one. Sometimes you define the first and second, so then you would start with the third. You just start with whichever one you didn't do, yeah. What is R here? 1/2, good. So A sub 1 is negative 4/3. A sub n is equal to negative 4/3 times A sub n minus 1. And since I only did the first A, then I start at 2. Then my explicit A sub n is going to be equal to A sub 1, which is negative 4/3, times R, which is 1/2, to the n minus 1 power. What questions do you have? Wait. What did I do? Did I do it wrong? R is 1/2 because I'm dividing by 2 each time, basically multiplying by 1/2. 4/3 times a positive 1/2 is going to be 4/6, which reduces to 2/3. Oh my gosh. Okay, there. That's why I was like, what? I don't know. Where did I mess up? I did totally mess up. Thank you. Yes. I was wanting to see if y'all were paying attention. Good job. Okay, this is 1/2. Thank you. All right, we good? All righty. So go ahead and glue or tape this in. Yes, you can. 16 through 21 you can omit. No, it's just, well, I think we are going to do those things in pre-AP. We're just not doing the second part of the notes. So we just didn't do that part of the lesson. It's not that you can't do those.